So on this section, I want to specifically talk about the sum and difference of two cubes formula. Now, before we even begin discussing the sum of two cubes or difference of two cubes formula, let's identify what perfect cube numbers are. So what are perfect cube numbers? Let's make a list. Could anybody give me a perfect cube number? 9 is not a perfect cube number. 9 is a perfect square number. 8. 27. Okay, so you got 8. Actually, you could technically start with 1, because when you say 1 cubed, 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 is 9 times 3 is 27. 4 times 4 is 16 times 4 is 64. 5 times 5 is 25 times 5, 125. And 6 times 6, 36 times 6, 216, I think. And of course it goes forever, just like perfect square numbers go forever. But we have to kind of be familiar with at least these numbers. That way we know when to use the sum or difference of two cubes formula. All right, so we're going to memorize two formulas, and right now I'm going to show you how to memorize those two formulas. The formula is always going to be a binomial times a trinomial. A binomial times a trinomial. 2 terms, 3 terms, okay? Now, the sum of two cubes formula, obviously we call it sum because this one has a plus sign. This one's the difference of two cubes because, you see, you got two perfect cube terms here, two perfect cube terms here. This one's sum, this one's difference. So you have the sum of two cubes formula and the difference of two cubes formula. Both of those formulas have a binomial times a trinomial. A binomial times a trinomial. Both of these formulas start off with exactly what you have here without the cubes. So this binomial will be this exact same thing without the 3's. So just a plus b. The trinomial, whether it's on sum of two cubes or difference of two cubes, it's the same exact thing. Start out with a squared, end up with b squared, ab in the middle, okay? Now, if you have a plus right here, then the middle term's sign has to be a minus. But if you have a minus, then that middle term sign has to be a plus, okay? And what about the a squared and the b squared? They're always positive. A squared is always positive, b squared is always positive. How could we remember that? Anything that you square will always be positive, right? -3 in parentheses squared gives you a positive 9. So that's just a little trick to remind you that a squared is positive, b squared will always be positive. It doesn't matter which formula we're using, okay? So once again, if you have a difference of two cubes, it's going to be a binomial times a trinomial, and the binomial will be this exact same binomial without the cubes. So you have a minus b. You're always going to have a squared at the front, b squared at the end, a, b in the middle. If this binomial has a minus sign, then the middle term of your other trinomial has to be the opposite of that, which is a plus. So we have to memorize this. The more we talk about it, the more you'll be able to memorize it, right? So that is the formula itself, kind of like the quadratic formula. Remember, x equals -b plus or minus the square root of b squared minus 4ac all divided by 2 times a. And then once you identify your a, your b, and your c, plug it into the quadratic formula. Right here on this formula, you need to identify the a and the b. Then you could plug it in right here into your a's and then your b's into your b's, right? So in order for us to identify a and b, we must rewrite it like this. Parenthesis cubed plus parenthesis cubed. Or if you see a difference of two cubes, then you're going to write it parenthesis cubed minus parenthesis cubed, okay? If you don't do this, you're probably going to make a mistake and not identify a and b correctly. Okay, so let's jump to the first example here. And what do we have here? Do we have a sum of two cubes or a difference of two cubes? Difference, right? The minus sign is difference. So even though you have your formulas already written right there, don't look at them. Let's just write down a cubed minus b cubed equals a binomial times a trinomial. Notice that I did small parentheses and I did some big parentheses. Okay, the binomial is in the small, the trinomial is going to be in the bigger. Okay, Now, just to help you guys memorize it, how do we get this first binomial? You just ignore the 3's, right? You delete the 3's. What do you have in this first binomial? A minus B, right? A minus B. Okay. Now, the trinomial always has the A squared at first, B squared at the end, AB in the middle. And if this was a minus, then this middle sign has to be what? Plus, that's right. And of course, the B squared is always going to be positive, right? And the A squared is always going to be positive. So again, I want the whole purpose of the time we have in class right now, or on this video that we're spending time on this video, is memorizing the formulas, okay? A binomial times a trinomial. Now, in order for us to be able to use this formula, we need to identify what A and B is. Now, if you don't set this up like this, you might think, oh, my A value is x to the third and my B value is 8, but that would be wrong, okay? That's why we set this up, parenthesis cubed minus parenthesis cubed. Now, we got to ask ourselves, what belongs right here in order for it to still be x to the third? What belongs right here in order for it to be an 8? What belongs in here? X, right? And what belongs in the other parenthesis? 2. That's the way to get 8, because 2 to the third power is 8. Again, this right here, the only purpose of writing it like this, maybe I'll put a little cloud around it, because that's not really part of your formula. The only reason why we do that is to identify your A value and your B value. The A value is x, your B value is 2. Now that you know that your A value is x and your B value is 2, now you could set up your formula, the binomial times the trinomial. So what is this binomial going to be? That's right, x minus 2. So let's write down the x and the minus 2. That's our first binomial. And again, that first binomial simply comes from taking the powers of 3's and getting rid of them, and you'll have an x minus 2 left over. That's what we write. Now the trinomial, I do recommend us to use parentheses when we plug in our a's and b's into the trinomial. What do I mean by that? Well, we need an a squared. I'm going to put parentheses squared. And then we have plus ab. I'm going to put plus parentheses, parentheses. And then at the very end, plus b squared plus parentheses squared. And now I'm going to plug in my actual a value. What's my a value? My a value is just x, remember? And my a value is just x. My b value is what? Just 2. Okay. And now we're going to simplify the trinomial that has the parentheses. So the trinomial, well, first of all, the binomial, it's already simplified, x minus 2. But that trinomial, x in parentheses to the second power, that's simply going to be x squared. The plus x times 2, I'm going to put plus 2x. And the plus 2 squared, that's really going to be a plus 4. Are you with me? Now, you might be thinking, well, why the heck did we do these parentheses? It's kind of like a waste of time. I already know that x squared is x squared. I already know that x times 2 is 2x. The reason why I want you to practice with parentheses, especially right now that we're barely starting this lesson, is because sometimes you might have like a 27x to the third. Instead of an x to the third, a 27x to the third, which would mean that right here you would have a 3x, right? 3x. And if you did have a 3x right here, your a value being 3x, you would have to plug in a 3x right here. And if you didn't have the parentheses, you might make the mistake of it being 3x squared, and it's not 3x squared. It's 3x in parentheses squared, which would technically be a 9x squared. So to make a long story short, why am I putting parentheses here? To help you or to prevent you from making mistakes on more complicated problems. But anyway, this cubic binomial is in factored form right here, this binomial times this quadratic trinomial. Believe it or not, if you were to distribute x times x squared, x times 2x, x times 4, negative 2 times x squared, negative 2 times 2x, negative 2 times 4, combine all the like terms, everything will eliminate except your first term being x to the third and your last term being negative 8. So that's how to use the difference of 2 cubes formula to write it in factored form. Let's try another. So this is not a difference of two cubes. This is a sum of two cubes. So right above, just for the sake of practicing writing our formula down, let's all write down a cubed plus b cubed equals, put a binomial parenthesis and a trinomial parenthesis. Smaller parentheses, bigger parentheses. And without looking at your formula, what belongs in this first parenthesis, the first binomial?
A minus A plus B.
A plus b. Now, how do I know it's a plus? Remember, it's just ignoring the powers of 3. Get rid of those 3's. What does it say? It says a plus b. Now, over here, what do we have in the trinomial? A squared minus, good call, the middle terms will be ab, and plus the last term what? B squared. Okay, so that is the formula. That's what we have to have memorized. That's what we're practicing here, memorizing these formulas. Okay. Now, it's essential to write it like this in order to identify the A and the B. Like, it's not really part of the formula, but it's essential to be able to know what is your A value that we're going to plug in right here, and right there, and what is your B value that you're going to plug in right here, right there, and right there. So what belongs in this first parenthesis, and don't say it out loud, and what belongs in the second parenthesis that will truly give you the 8c to the third and the 27d to the 6th. I want you guys to talk to a partner. I want to pause it, and then we'll come back. Okay, once again, even if you're not too sure about it, you got to think what number and what letter belongs in here, so when I multiply it with itself 3 times, it'll get me back to the 8c to the third, and like you guys just said right now, 2c is the correct answer, right? 2c times 2c is 4c squared times another 2c will take you back to the 8c to the third. So what value belongs, or what monomial belongs in here that when you multiply it with itself 3 times, it'll get you back to 27d to the 6th? Anybody? 3d to the 2nd. Okay? I mean, 3 to the 3rd, that's 27, and a power to a power, you multiply, that's d to the 6th. So 27d to the 6th is definitely 3 to the 2nd in parentheses to the 3rd power. Again, the only reason why we set this up like this is to identify what our A value is and what our B value is. Once we know the A and the B, now we could actually plug it into the formula up here with those A values of 2c and the B values of 3d squared. So I would put equal sign and then down here put a binomial times a trinomial. Smaller parentheses, bigger parentheses. Okay? Now, what is this binomial? Remember, it's just ignoring those cubes. So what belongs in here?
2c plus 3d squared.
That's right. 2c 3d squared with a plus sign. Exactly the way it looks up here without these 3's. Now, the trinomial, I always recommend using parentheses, right? Especially when it's a little bit more complicated like this one. So I'm going to write it out. Instead of a squared, I want to put parentheses squared. What's the middle term? It's going to be a minus ab, so I'm going to put minus parenthesis, parenthesis. And then finally at the end, plus b squared, plus parenthesis squared. So what is the a value that we're plugging in? 2c. And what is the, a value again is 2c. The b value? 3d squared. Thank you very much. And also 3d squared right there. And now let's simplify this trinomial. And I hope you guys see why we use parentheses, because if you didn't use parentheses, you'd probably make the mistake of saying that the first term on your trinomial is 2c to the 2nd, but we know it's not 2c to the 2nd. It's actually what? 4c to the 2nd. So don't make that mistake. That's why we use parentheses. So you could actually get 2c times 2c, which gives you 4c squared. Now that middle term will be a minus 2 times 3 is 6. C times d squared is simply c d squared. It's just writing it together. Last but not least, plus what? What's 3d squared times 3d squared? 9d to the 4th. Perfect. And the first binomial, you just bring it down. 2c plus 3d squared. This is the factored form. This binomial times this trinomial is a factored form of this original binomial. Okay. What is factoring after all? It's a multiplication problem of two items, a binomial times a trinomial, that if you were to distribute and combine like terms, it'll give you this answer above. And just like before, why the heck do we want to do reverse multiplication? Why do we want an answer and then get to the actual multiplication question? Because if you do have something times something else and it's equal to 0, then you're able to split it with zero product property and solve those two simple equations. So let's use our newfound skill right here on solving this equation. It says x to the third plus 216. So I hope you recognize that this is a perfect cube term and this is a perfect cube term. So I'm going to rewrite my sum of two cubes formula. A cubed plus b cubed equals a binomial times a trinomial. And the binomial will be the exact same thing, a plus b. And the trinomial will be a squared in the front, b squared at the end, and in the middle you have to have a minus sign because it's opposite of the plus with the ab together. ab together. And that b squared is always positive. Again, the first goal of this lesson, of this video, is to get you to memorize these formulas, how to be able to come up with these formulas on your own. Okay, so this is the setup. You got to put parentheses cubed plus parentheses cubed. Now, what is the a value that belongs in here and the b value that belongs over here? X and 6. Good job. Now, once we know that the a is the x and the b is the 6, you're going to be able to take that x and put it right there, and the 6, put it right there. Take the x right there, and the b right there, the 6 and the 6 right there. Anyway, let's set it up. We will have a binomial times a trinomial. The binomial will be what? X plus 6. The trinomial will be what? Now we could use parentheses, but because we have simple terms like x and 6, let's not even worry about it. Let's just plug it straight in. X squared minus 6.
X squared plus 36.
Okay, 6. Remember, the middle term is minus a times b. So minus x times 6, that'll just be 6x, right? And then the last term will be plus b squared. So I'm going to put plus, what is b? It's 6. 6 squared is 36. Are you with me? Now this is equal to 0. So it's still equal to 0. And again, we want it factored because now you have something times something else equaling 0, which means the first something could be equal to 0, or the second something could also be equal to 0. So that first something, if I solve it, I'll get an answer, x equals negative 6. Now the second something, we need to solve it. You might be thinking, well, it is a quadratic trinomial. The a value is 1. Maybe I could factor again and then split it and solve. But when you start thinking about what times what is my c value of 36, that if I combine together is my b value of negative 6, you're not going to be able to find that combo because this is not factorable. All right? Like even if you tried, okay, make a list. 1 times 36, 2 times 18, 3 times 12, 4 times 9. None of those pair of numbers combines together to give you negative 6. It just doesn't work. You can't factor it. So we cannot factor it. This is a quadratic equation. I was trying to factor it to be able to split it and solve it, but we can't factor it. What could we always fall back on to be able to solve any quadratic equation? Again, focusing just in on this quadratic equation right now. The a value is 1, the b value is negative 6, the c value is 36. What could we do to solve this equation if it's not factorable? Quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2 times a. And of course, whenever you use this quadratic formula, it's a great idea to rewrite it with parentheses instead of the letters. And let's plug in our values. The b value is negative 6. That goes in right here and right there. And then the a value is 1. That goes up here and down here. And the c value is 36. That goes over here at the end. So we definitely need to do some math here working on this quadratic formula, especially focusing in on the square root part, right? I mean, the minus 6, that's easy. That becomes positive 6. But when I start working on the inside, on the discriminant, I have a negative 6 to the second power. That's really a 36. And then I have 4 times 1 times 36, and there's a minus sign. 4 times 1 is 4. 4 times 36 is 144. Is that right? Anybody with the calculator verify that for me? I think 4 times 1 times 36 is 144. Anyway, we have 36 take away 144, and that becomes negative 108. And that is still the discriminant inside the square root. Okay? So let me rewrite what I have so far. I have a positive 6 plus or minus the square root of negative 108, all divided by 2. Now, that square root of 108, we're going to simplify it further. Okay? 108 is not a perfect square number, but we could rewrite it with multiplication to get a perfect square number. Or if you have a Casio calculator, you could just type it in and it'll simplify it for you. But in case you forgot the minus sign in a square root, you can't do that. It comes out and it becomes an I. So you have an I on the outside, and then you have the 108 that could be rewritten as 36 times 3, I believe. And then you could split that root. So you really have I times the square root of 36 times the square root of 3, which ends up being I times 6 times the square root of 3, which is really 6I square root of 3. So this square root of negative 108 ends up becoming 6I square root of 3, and we're going to replace the square root of negative 108 with 6I square root of 3. So what we really have is 6 plus or minus 6I square root of 3, all divided by 2. So we could at this point just reduce all 3 terms by 2, or you could technically take the divisor of 2 and split it to each of those 6's. Either way, you're going to get 6 over 2 plus or minus 6I square root of 3 over 2, which becomes 3, and a 3 right there. So your final answer will be 3 plus or minus 3I square root of 3. I know what you're thinking. Man, I can't believe all of this fun is for free, right? You're not paying admission for this. So entertaining. Yes. Look at that. It's like a work of art. Makes me want to get some spray paint and go solve this on a wall or something. Tag it. Anyway.
Well, then you get arrested.
Then I get arrested and I wouldn't be able to teach you guys. I know. That's why I don't do it.
Why don't you replace them?
Anyway, listen up, guys. Let's review something here. This is a cubic binomial. If I were to graph it on Desmos, where would my end behavior be at? Quadrant 1, 2, 3, or 4? It's an odd degree function.
Oh, 1 and 3.
Quadrant 1 up here and quadrant 3 down here, huh? Now, it's like a snake-like curve, but where would it actually cross the x-axis?
-6.
At -6, exactly at -6. It would cross somewhere over here at -6. So, what else? This third degree equation, it really does have 3 answers. One of them's real, the other 2 are imaginary. That's why it'll only cross at one location. Just trying to link everything that we've learned and put it all together. Let's take a look at this last one up here, upper right corner, and we're going to stop after this one. It says the sum and difference of 2 cubes formula can also be applied on division problems. Well, does anybody remember from semester 1 how to do this division problem? There was long division where you put this inside the box and this outside the box, but there was a quicker way. Anybody remember? Synthetic division. In synthetic division, and we might as well jot this down, and I would write it really small because we're going to do it both ways. We're going to do it the old way from semester 1, where we would plug in what number right into this box. Anybody? -3, perfect. Now, just to review, why is this -3? Because if I had, let's say I started out with a polynomial equation and it was equal to 0, and I wrote it in factored form, I'd have like parentheses x plus 3 times parentheses something else, and if it were equal to 0, I would set each of those equal to 0, and if I did set x plus 3 equal to 0, and I solved it, I will get negative 3 as an answer. That's why I'm plugging in a negative 3 into this synthetic division box. And we also need a list of numbers over here, and that list of numbers is really the coefficients of all of your terms. The coefficients are the number in front of all of your terms in this third degree polynomial, representing even the ones that don't have powers. Like the missing powers, you got to represent them with zeros. So what's my leading coefficient? 1. And then after the 1, what do I need? 0, because there is no x squared. And then after that? 0, because there is no x. And then at the very end, the constant? 27. Okay, so this is the setup for synthetic division. And just to remind you guys, as you go down, 1 plus what, there's nothing there, is 1. As you go up, you multiply. Negative 3 times 1 is negative 3. As you go down, 0 plus negative 3, what do we get? Negative 3. As you go up, negative 3 times negative 3, what do we get? Positive 9. As we go down, 0 plus 9, what do we get? 9. As we go up, we multiply negative 3 times 9, negative 27. And this value that we get 0 is our remainder, right? Now, this is like part of a future lesson, but I might as well throw it out to you right now. These blue numbers will produce our depressed polynomial. That's what it's called, a depressed polynomial. Why is it depressed? Because we've been doing this lesson for 45 minutes. It's a long lesson. Yeah, for real. No, but yeah, this is a depressed polynomial, and let's write it. Remember, this last number has to be your constant, which means this has to be x and this has to be x squared. So our depressed polynomial will be x squared minus 3x plus 9. And believe it or not, this is our answer to the original division problem using synthetic division. Now, what they want us to do, they didn't want us to do that. They wanted us to use the formula. Now, think about it. X to the third plus 27 divided by x plus 3. I could have written it that way, right? Now, I could, okay, I'm sorry. So let's identify what our A value is and our B value is to be able to plug it into our formula. And our formula will ultimately be a binomial times a trinomial over that x plus 3 that's already down there, right? So what is my A value that belongs right in here? X. And what's my B value that belongs over here? 3, right? To get 27, that has to be a 3. So what is my first binomial if I know that it's x and 3? What's my first binomial? X plus 3. Okay? And what is my trinomial? And since it's only an x for A and a 3 for B, we don't have to use a parentheses. What will that trinomial be? Minus x times 3 is 3x. Whoops. 3x, and then plus 3 squared is 9. That's right. Okay, so we have factored it. And check this out. Now we have something times something divided by that same something that you're multiplying by, which means that you could technically cancel this entire binomial x plus 3 with that binomial x plus 3. And this is your answer. X squared minus 3x plus 9. It is the same exact answer. If I could actually move this screen, because it's not responding. Why is it not responding? So there it is. Same answer. X squared minus 3x plus 9. X squared minus 3x plus 9. It explained in two different ways. Why am I showing you this way? Reviewing synthetic division, because we will be using synthetic division and synthetic substitution in a couple of days, maybe tomorrow, but definitely later on this week and also on the test next week.